So there are two kinds of exceptions that as a programmer you'll have to deal with. One is checked exceptions that Java requires you to handle, and unchecked that you may or may not handle. They may or may not show up. So like dividing by zero is an arithmetic exception, number formatting, like when you're trying to save a double is an int, that kind of thing. So we're going to take a look at one of the ways to handle our unchecked ones. We already talked about throws IO exception already, so we're going to address the try catch. So let's talk about the try catch. So come back to that lesson 36 program that we created at the beginning of this lesson. And what we're going to do is we're going to interact a little bit with the keyboard. Let's have a little fun with it. So we're going to need a scanner, which means we're also going to need to come up at the very top and import java.util. There we go. So now we're using our scanner. So what we're going to do is we're going to interact. So we're going to ask the user to input two different numbers and divide them. So we ask the user to put in a number. We import that first number. We ask the user to import a second number. To input a second number, we import that second number. Then we're going to need to calculate. So n total equals n1 divided by n2. And then let's print that total. Pretty straightforward. This is probably a nice refresher for you guys to go back and think about all the stuff we used to do. So hit run, enter the first number, we'll do 5, enter second number 4, it's 1 because, you know, it's integers and all that good stuff. But that's fine. We can also test it with numbers we know are divisible, so like 12, 4, and it gives us 3. Now what if we run it and we say 12 divided by 0? It's going to give us an exception, divide by 0, an arithmetic exception. So what we're going to do is we're going to put in a try and catch. I mean, how annoying would that be if you were this huge stock market program and someone divided by 0 and killed the whole program? That's highly inconvenient. So what we're going to do is we're going to design ways with the try catch to make sure that doesn't happen. So we're going to try this code. So if you come in above it, do try and open the bracket, then come on down and close the bracket. So we're going to try this entire code. We're going to be looking for an error inside of it. So this way, what it's going to do is if it comes back with an error, it's going to actually do something instead of just shutting down. So once we try this code, it's going to find, if it finds an error in here, it's actually going to catch it, and then we're going to come down and we're going to do catch. This is another keyword. And there always has to be a catch after a try. So what we want to do is we want to try and catch any exception or error. So what we want to do is put in exception, and then we can just call it E here. So this is like saying int I, but it's looking for exception, and we're just going to name it E. And within our catch, we'll put some sort of message. So like, do not pass go, do not collect $200. Now, if something is in your try block and it works fine, it will never go into the catch. But if there's some error in try, it will. So let's go ahead and run it. Do 12 divided by 3, 4, just like before. Now if we do 12 divided by 0, instead of having an error, it gives us this little pleasant but semi-condescending term. The last thing we're going to look at is the finally block. So you have a try, you have a catch, and then you can have a finally. This is optional. You do not have to have this, but this code is guaranteed to execute. Whether you catch an error, whether you don't catch an error, this block is going to execute. So this finally block would be a really good idea if you were like writing a file and maybe you had an error in here to actually save and close the file that you're writing to. If you look back at our 36 project, you may notice that whenever you go to a bank, it doesn't just like end your transaction. It gives you something like, thank you for using Bank of America, or something along those lines. So what we're going to do is put in a finally. No matter what we do, it's going to say, thank you, come again. So we'll say if we enter the first number, 12, second number, 6, it gives us 2, and then says, thank you, come again. if we put in 12 and we divide by 0, do not pass go, do not collect $200, thank you, come again. So it forces it to actually operate anything inside that finally block. There's even a thing in your book on page 217 where you can design your own exception types and make it do whatever you want. I'm not going to have you guys do that right now, but it's something that you could do if you really got into it. Just a few things for you to know about exceptions before you go off into the world. So, exceptions are a superclass. They have subclasses. File not found is a subclass of IO exception. IO exception is a superclass. So if you have two catch statements, you have to go in subclass and then superclass. So subclass first, then superclass. Next up, if you throw IO exception in a main or a superclass, that throwing IO exception also trickles down into all the subclasses. All right, for try catch. So if you have a try block inside of like an if statement, you have to have the catch also inside of the if statement. Remember scope, that applies to try and catch also. You can also have a try without a catch as long as you have a finally. And if you use a finally, you have to have a try. So you can't just throw finally into every single program you write. You have to have a try in there. All right, good luck. You guys have some questions, and you also have a project for this lesson. Let me know if you have any questions.